All right, y'all. Happy Monday. Let's do the bell ringer. It says, the image shows the genotypes of two parents. Here's the image. Here's the genotype for parent 1. Here's the genotype for parent 2. The big B represents blue flowers and the little b represents white flowers. So I know I said this on Thursday and Friday. Whenever they tell you which trait is dominant or which trait is recessive, you should write that stuff down because it's going to be super helpful if you do. So like it says, the big B, which means it's dominant, right? Big B means dominant, is for blue, and the little b, which is recessive, is for white. So immediately, actually, let's go a little bit extra here. There are 3 different genotypes you can have, right? You can have big B, big B, big B, little b, or little b, little b. So immediately, since we know all of that, we know that the 2 big B's, since there is that dominant allele, and remember you only need just one dominant allele to be present, since we have a dominant allele here, this genotype would give a blue flower. And same thing for this one right here. Let me zoom in. There we go. For this one right here, we also have a big B, and since that big B is the dominant trait, it's going to dominate over that recessive allele. It's not going to let it say a word. So this one is also going to be a blue flower. And down here, since there's finally no big, bad, dominant alleles present, we have 2 little b's. It's time for that recessive allele to shine, so we're going to see a white flower with this genotype. Okay. Back to the question. Sorry, I got a little carried away there. It says, a student lists possible offspring. Oh, we know what that means. Possible offspring of a cross between the 2 plants. So here are different possible offsprings that these 2 parent plants could have. So it says which 3 offspring are actually possible given the 2 parents. So you need to look at each of these offspring and pick which one of these are actually possible. Which one of these offspring can actually happen if these 2 parent plants reproduce. When you see, remember that cheat sheet that said possible offspring, when you see possible offspring, you know, I'm going to have to make a Punnett square. So let's go ahead and do that using our 2 parents. So let me zoom out here, scroll down a little bit, give us some room. Our 2 parents are parent 1, capital B, lowercase b, which we know is going to go on top of our Punnett square, right? And then our second parent up here is lowercase b, lowercase b. So let's fill it out because remember each individual box is going to show a different possible combinations of alleles that the offspring can receive from each parent for the trait of flower color. So if we bring down our capital B and bring over our lowercase b and continue that for each box, so bring down our little b, bring over our little b, again bring down that big B, bring over that little b, and bring down the little b, bring over the little b. Great. We just killed that Punnett square. That was easy. So now we know the different possible genotypes of the offspring, right? So we got to go through this list one by one. And what we're going to do is if it is a possible combination for the offspring, if it is shown in our Punnett square, we'll put a little check. If it's not in the Punnett square, we'll just cross right through it. And that's going to help us pick from the list down below. Okay, so the very first one says a plant with a blue flower. So if we look, and actually you're gonna see some movie magic right here. Oh my gosh, did you see that? That was amazing. Okay, so if we take a look, we already said if it has the genotype of big B, it's going to be blue. And if it has the genotype of big B, little b, it's also going to be blue. So do we have any of these genotypes in the Punnett square? Why, yes, we do. If we look right here, we've got a big B with a little b. And over here, we've got a big B with a little b. So I totally think that choice 1 is possible. Choice 2 says a homozygous plant showing the dominant phenotype. Whoa, there's those words. We know that homo means something and hetero is the opposite type, means something else. We know, we've talked all year, homo, that prefix means same, and hetero means different. So if we're talking about a homozygous plant, we know that the two alleles are going to be the same exact letter. And it says showing the dominant phenotype. So we are going to have two dominant alleles present because they're the same. Homo means same, and dominant, we're going to have, the dominant allele. And the dominant allele, again, is that big uppercase letter. So we're going to have a big B and a big B for our homozygous dominant. Do we see any big B's in our Punnett square? No, I see big B little b's and little b's, but I don't see any that are both big B's. So, sorry to number 2. Not possible. Choice number 3 says a homozygous plant. There's a homozygous again, but we're showing the recessive phenotype. So since recessive is lowercase, we want to have 2 lowercase. So lowercase b for recessive homozygous. Do we have any of those? Oh, yes, we do. We got a little b, and a little b. So that is definitely possible. So I like choice number 3. Congrats, number 3. You made the cut. Choice number 4, we're almost there, says a plant with a white flower. And look, over here, we decided if it has 2 recessive alleles, that it must be white. And we just said that we have a homozygous recessive genotype as a possibility. So choice number 4 is also possible. All right. So let's take a look at our list here. So 1, 3, and 4 are possible. So that is going to be not A, because it says 2, and we said not 2. B also says 2. Ooh, choice 3, 1, 3, and 4. Absolutely. And choice D also has 2 in it, which we said is incorrect. So it is going to be choice C. So look, as soon as you do your Punnett squares, the answers, they just jump right out at you. So my goodness, whenever you see list the possible offsprings or what is a possible combination of alleles, please draw a Punnett square. Please just do it.